In this example, we're given the formula for a polynomial function g, and we want to find first the degree of g, and then we want to find the leading coefficient of g, and then we want to use the degree and the leading coefficient to describe the end behavior of the graph of g. So let's start by finding the degree of g, and remember the degree of a polynomial function is going to be the highest power of the input variable in the formula for the polynomial function. So the highest power of our input variable x in this formula is 5, so the degree of g is 5. And the leading coefficient of a polynomial function is going to be the coefficient of the term that contains the highest power of the input variable. So the highest power of the input variable again occurs in this term, and the coefficient of that term is -4. So the leading coefficient of g is -4. Notice the leading coefficient is not 3. It's not always the coefficient of the term that's written first. The terms of a polynomial formula can be written in any order. So the leading coefficient is -4. Now, we can use, again, the degree and the leading coefficient to help us determine what the end behavior of the graph of the polynomial function g is going to be. And let's review how that is done. So we have a little table here that describes how we can use the degree and the leading coefficient to determine the end behavior of a polynomial. So if the degree is even and the leading coefficient is positive, then the graph of a polynomial function is going to rise on the far left, and it's also going to rise on the far right. If the degree is even but the leading coefficient is negative, then the graph is going to fall on the far left, and it's also going to fall on the far right. If the degree is odd and the leading coefficient is positive, then the graph is going to fall on the far left, and it's going to rise on the far right. And then finally, if the degree is odd but the leading coefficient is negative, then the graph is going to rise on the far left, and the graph is going to fall on the far right. So in this case, our degree for the function g was 5, and the leading coefficient was -4, which of course is a negative number. So the degree of g is odd and the leading coefficient is negative. So that tells us that the graph of g is going to rise on the far left, and it's going to fall on the far right. So let's write that down for our end behavior for the function g. So the graph of g rises on the far left and falls on the far right. I'd like to say far left and far right, but you might, in describing the end behavior, just say the graph of g rises on the left and falls on the right.